Where we are going, boys and girls, we're going back to the river. And yes, this is Mr. Broussard, and it is getting kind of cold today, so I have to put my hood on. And we are going to the river. We are going to talk about waves, but we are not going to talk about water waves. We're not going to talk about the ocean. So why are we going to the river? Well, I want to show you something. I want to make a comparison between the ripples in the water of the river and today's topic, which is sound waves. Okay, so we are on our way to the river now. So just as a little review, we know that what was really traveling in the ocean was not the water, right? It was the energy going up and down in that water, right? Remember that ball that was staying sort of in the same place? Because it wasn't the water traveling, it was the wind energy. Well, today we are going to look, as I said before, as I mentioned before, at sound. And the reason that we're coming to the water is because, well, we cannot really see sound, but we can actually see the ripples in the water. And I want you to be able to understand, I want you to be able to see it, okay? To see how sound works. So I'm gonna have to go and grab a big rock again. Oh, it's getting cold. So we're heading to the river again, to where the pile of rocks is, and we're gonna throw another one in the water, okay? Even though our lesson today is not about water waves, but I wanna show you something because we cannot see sound. So by looking at this, we'll be able to understand how sound travels, okay? So let's go to the pile of rocks. And here is the pile of rocks. Let me grab a big one here so that we can throw it in the water. There it is. And now carefully, let me get close to the water. Looking at the ground here because it can get slippery. It's kind of muddy, it's been raining. And let me throw the rock into the river. There it goes. And there are the ripples. Now, let me ask you something. If we are going to talk today, I already told you that we're going to talk about how sound travels. Why do you think that I came to the river again to throw a rock and see those ripples? So why do you think that I came to the river if we're going to talk about sound? What do you think? So think about it for a moment, pause the lesson, think about it, and then answer, okay? Why is it that I came to the river to make ripples in the water? If we are not going to talk about water, we're going to talk about sound. So why? Why do you think? Well, because we cannot see sound and we can see the ripples in the water. Okay? We cannot see how sound travels, but we can see that. And sound travels pretty similar to those waves. It travels pretty similar to ocean waves. That's why I wanted to show you that, to refresh your memory as to how water waves are made so that we can then talk about sound. So let's go to our learning target. Our learning target is, how does sound travel? Okay, how does sound travel? And also, we want to find what kind of wave is sound wave, because we can classify waves into two. We already talked about that last week, okay? So how does sound travel? We want to really dig deeper as to how sound travels, okay? So as we head back to the house, I want to ask you another question. Remember that we said that wind energy needed that water to move through, right? So what does sound need to move? What does sound need to move from one place to another? What does sound need to move? What does sound need to move from my mouth to somebody's ear? What does it need? Do you remember what it needs? It needs one of three things. Think about it. You can look back in your notes. It needs one of three things. And it's a liquid like water, or it needs a solid like wood, or it needs a gas like air. We cannot see air, but I'm pointing to the sky, to where there is some air going by, and even some little birds were flying by. Whoa, it's getting cold. So, in order for sound to travel, there needs to be air, or there needs to be a gas, or a solid, or a liquid. Okay? Remember that. You must have that, or sound cannot travel. Well, it was getting really cold over there, so I can take my hood off, and let's continue with our lesson. Gas, liquid, or solid. So now I'm going to ask you something based on these three things. If we were on the moon and I was trying to teach you a lesson for science, okay? And I was talking and talking and talking and talking. Would you be able to hear my voice? Yes or no? And why yes or why not? And that's a no. Because there is no air on the moon. So sound cannot travel. It will sound like this. I would be making the sound here, but it could not travel to your ears. How about if we were underwater and we turn a radio on? Would we be able to hear the sound from one place to another? What do you think? If yes, why? If not, why not? So it is a yes, because sound can travel in water. Remember? How about if we were outdoors in this mountain and we were trying to talk to each other? Would you be able to hear me? What do you think? Yes, why, or no, why not? All right, so we know that sound needs either liquid or gas or solid to travel. But how does it happen? And remember our demonstration at the beginning of the lesson, how I threw that rock and the ripples were happening? Well, let's examine how that it is similar to how sound travels, okay? Do you remember this word from last week? Disturbance. You remember that word, disturbance? What was the meaning of that word? It is the interruption of a settled and peaceful condition, okay? Like opening your mouth and your vocal cords making a vibration, okay? Or like hitting a drum or playing a piano, right? So when that disturbance happens, whether it is music or whether it is drums or whatever the sound was, let's say speaking, right? This disturbance happened over here and it hit the particles of air. And then those particles of air hit the other particles of air. And those hit the other particles of air. And the other particles of air. And they keep hitting each other and each other and each other and each other and each other until it reaches someone's ear. So it goes like this. One hits the other and comes back a little. And the other one hits the other and comes back a little. And the other one hits the other and comes back a little. So it works like this, you see? or like this. You see? They're hitting each other, they're hitting each other, they're hitting each other. You see it? See? And that's why we think of them as waves, because we can diagram them in that way. And we can actually name, again, the top, crest, and the bottom, trough. You see this diagram right here? The top right here is the crest, and right here is the trough. And we want to measure waves, especially if you go into a job that requires that. You need to know how to do that. So when you go from crest to crest, we call that the wavelength, okay? And when we go from right here to where everything was at peace, and then we had that, what do we call it? Disruption? No, not disruption. What do we call that? Disturbance, I remember. So this is when everything was at peace, and then the disturbance happened, and the wave went over there. So from here, the peaceful moment to the disruption over here, that's called the amplitude. So we could say how tall that wave is, and the wavelength over here is from crest to crest, how long that space in between crests, in between waves are, okay? And just to give you another example, it would look something like this, okay? So right here is the layer hitting that layer and then coming back and hitting that layer and coming back and hitting that layer and coming back. And so we diagram it like this, okay? You see it? We talked about this word, remember? Longitudinal waves. And sound waves are longitudinal, okay? And here is a really good example of why, okay? So they are hitting each other this way, and the sound is also going that way, okay? Longitudinal. So the direction of the vibration of the particles is parallel to the wave, okay? So sound waves are longitudinal waves. But if we go back to ocean waves, remember that it was pushing down and up. And even though the waves were, the energy in the waves was moving to the shore, it was really up and down, up and down, up and down. Remember? Remember about my grandson, the story about my grandson? That's right. So those waves are called transverse. Transverse, okay? Because the energy is moving in one direction, but it's caused by something pushing down and then up, down, and up. Okay? So those are transverse. So sound waves are longitudinal, ocean waves transverse. Okay? It's important to remember that and the reason. Now, I want you to take about 7 or 8 minutes, and in your notebooks, I want you to explain how does sound travel. So everything that you learn about sound, how does it travel? You're going to explain it in your notebook. So take your time and explain that, okay? And then we'll come back together to share with the rest of the class. So now you know much more about sound and how it travels, and what kind of waves it travels, and what does it need to travel, and what happens to the different layers of air if it's traveling through air. So you know a lot more about sound traveling, okay? So now you can go and tell your little sister and your brother and even your parents. Maybe they don't know, because I didn't know until I started studying to teach you the lesson. So you know a lot about sound, and you might end up with a job that has to do with sound. Bye-bye, have a great day, and I will see you next time. Remember, science is everywhere.